Okay, go ahead and get out a piece of scratch paper and be ready to follow along for the math on the spot video. Let's go ahead and get started.
So I fold the net over here, then oh, hi! Hey, I was just actually folding up, making a three-dimensional figure from a net, which actually reminds me of a really interesting riddle about Rhiannon, who was actually thinking about something interesting related to nets. Let's check it out. Now, Rhiannon draws this pattern and labels each square. Can Rhiannon fold her pattern into a cube that has letters A through G on its faces? So you can see now, here's the net. In fact, this is exactly the net that I was working with here live. You can see it fits over perfectly. And we see that we have all these squares labeled A, B, C, D, E, F, G. And the question is, can we take this net and actually fold it up to make a perfect cube? That's the question. Well, the answer is, let's see. Now, how many sides does a cube have? Well, it has 6. So if we were to fold this up, then these would each represent one of the 6 sides. But check it out. 1, 2, 3, 4, 5, 6, 7. This actually has too many sides. This actually has too many sides. So the net for a cube has only 6 squares. And so, in fact, this shouldn't work. And let's just try it. We can actually just try it right now. If you try to actually take the net and connect all of these together, like this, and then bring these sides in, then look what happens. See, we get this little kind of box-like thing. So that's looking like a cube. But you see what happens? I've got one too many sides. And so if I try to affix it, I'd get like a house-shaped thing. You see, it wouldn't fit all together. It's a house. So there's one side too much. In fact, you can see that 7th side. You see we counted 7? There's the extra one. So in fact, if I were to cut, here, I'll do this right now just for fun. If I were to actually cut my net, this is not Rhiannon's, but just mine, and remove that 7th square, there's the 7th square, then the 6 squares that are left actually form a net that produces a perfect cube. There's the perfect cube. Isn't that kind of cool? I think it's kind of neat, actually. I like looking at that. And so you can actually see it visually if you wanted to. So that really is the net for a cube. 1, 2, 3, 4, 5, 6, which we fold up, which is exactly what you and I just made ourselves right here. There's that version of it right there. But if we have 7, like Rhiannon had, then in fact, that is too many. So Rhiannon's pattern has 7 squares, and there are only 6 square faces that make up a cube, and so actually 6 squares to make the net of the cube. So, in fact, we see that we can visualize a three-dimensional object, a thing like a cube that has, length and width and height. We can actually visualize that using nets by, in some sense, unfolding it and collapsing it down. And sometimes a net can make a certain object, and sometimes it can't. Interesting to realize that we can visualize things on a piece of paper that actually require space. Have fun thinking about nets, and I'll see you soon.
All right, thanks for watching, and I'll see you on the next one.